In a previous video, we said that the measure of the arc from one point on the circle to another point on the circle. By that measure of the arc, we mean the distance measured along the circle from the starting point to the ending point. That distance is related to the angle of the angular sector or the circular sector, and it's related to the radius. The equation that relates those three quantities is this, that the arc length S is equal to the angle measured in radians multiplied by the radius. However, let's talk about what happens if there is a change as an object moves along the circle. Now, if the object is starting from this point, the angle that it makes with the original starting radius is going to change. So that angle theta for that particle moving along the circle will be changing. So we could rewrite this equation like this. We could say that delta S is equal to delta theta multiplied by r, the radius. Now you'll notice I didn't write a delta next to the r, and the reason I didn't do that is because r is not changing. As long as the object is moving in a circular path, the radius isn't changing. However, the angle is, and the arc length is. Now another thing that we can say is that these changes will take place over time. If this is an example of what we call uniform circular motion, then that means that the object is moving along the circular path at a constant speed all the way around the circle. So what we're going to do is divide both sides of this equation by delta t, the amount of time that goes by as the object is moving around the circle. In that case, we can say that delta S divided by delta t is going to be equal to delta theta times r over delta t. Now we can modify the right side of the equation here a bit by using the associative property of multiplication or division. We're going to group together the delta theta and the delta t. So we'll write it like this. Delta S over delta t is equal to delta theta divided by delta t multiplied by r. So what this is saying is that the rate of change of the arc length over time is equal to the rate of change of the angle over time, as long as the angle is measured in radians, multiplied by the radius of the circle. So one final step that we can make here for this equation is that we can replace the delta S over delta t by the symbol v, which stands for speed or velocity. So the speed or the velocity of the object moving along the circle is equal to delta theta divided by delta t multiplied by the radius of the circle. But we're going to make one last change here, right? So we said that v is the speed of the object that's moving along the circle. But we're also going to make a new symbol designation here as well. We're going to say that v is equal to the Greek letter omega, which looks a lot like a W, but it's the Greek letter omega multiplied by the radius. So that omega, we're going to call that the angular speed. And by angular speed, we mean the rate at which the angle is changing. That angular speed will be measured in, put a comma there, measured, make sure that, okay, measured in radians per second. Okay, and so this is the angular speed, which is the Greek letter omega. So that's an important equation. So the speed of the particle, or the speed of the object moving along the circle, is equal to the angular speed multiplied by the radius of the circle. And we'll want to keep that in mind. We'll come back to that.